Hello everyone, it's me, your friendly neighborhood math teacher, Mrs. Herrera, and today we'll be solving systems of linear equations by using substitution. So there's actually a couple of steps that we can remember that can help us as we go through the process of solving linear systems of equations by substitution. Yesterday what we did was we graphed the linear systems of equations, and we figured that the solution to a linear system is where the two lines on a graph would cross. And we're looking for the same thing here when we're doing substitution. We're looking for that point that's our solution where those two lines would cross on a graph. But we want to solve now without having to go through the process of graphing. This can be helpful if perhaps you have an equation in which the graph would not be practical. Maybe they would cross somewhere like at 20, 100, 150, and that graph would be really difficult to do, especially on normal graph paper. So substitution can be really helpful in situations like that. Let's take a look at our steps here. So step 1 says solve So step 1 here says solve for one variable in at least one equation if necessary. Then we go to step 2, which we're going to substitute the resulting expression to the other equation. Step 3, solve the equation to get the value of the first variable. Step 4, substitute that value into one of the original equations and solve. And finally, step 5 says write the values from step 3 and 4 as an ordered pair, x and y, and then we check. So that's say, oh my gosh, these are a lot of rules. I'm not really sure what it all means. I don't really know what it means when they say to substitute the resulting expression. So let's take a look at these steps one by one. The first problem we're going to do is we have two equations, y equals 2x and y equals x plus 5. If we think about the steps that we were given, step 1 said solve for a given variable, either x or y, doesn't matter. If we take a look at our two equations here I have this equation is actually solved for y. Y is alone on one side of the equal sign. Y is also alone on one side of the equal sign for the second equation. So in both of these equations, we have solved for y already. So we don't need to solve for a variable. Step 1 has been complete. So since step 1 is complete, we can now move on to step 2. Okay, step 2 says substitute the equation which the variable is solved for into the other equation for that variable. So for example, in this case, I have y equals 2x. So if I know this is what y equals, and this y are supposed to be the same, I can just take 2x and plug it in for y. So I'm going to do that here. I'm going to have 2x equals x plus 5. Step 3 asks me to now solve for the variable remaining. So I have x's here. That's a really good way to double check that you've substituted correctly. You should only have one variable left. And that variable in this equation is x. So I'm going to solve for x by subtracting x from each side here. And here I'm left with x equals 5. Step 4 then says, okay, now that you know what one of the variables is, plug that back into one of the two equations that you were given in the beginning. And it doesn't really matter which one. So let's go ahead and do it into the first one. I know that y equals 2x, that's my first equation. And now if I know that x is 5, I can solve for y. So I want to know what y equals when x is 5, and in this case, y is equal to 10. Now it should work out the same way. If I were to plug in y into the second equation, I should still, x as 5 into the second equation, I should still get y equaling 10. And that makes sense. Here, if I were to plug in 5 for x, I get 5 plus 5. 5 plus 5 is still 10. So either way I do it, whatever equation I choose, it shouldn't matter. I should still get the same x and y. Step 5 simply says write your answer as an ordered pair. So my x was 5 here, my y was 10, and I wrote that as my xy ordered pair. This is the point on the graph in which those two lines intersect. Okay, at this point I want you to pause the video. Go ahead and try this one on your own. When you're ready, go ahead and press play, and then you can check your answer. My final answer for this one is -2, 1. Okay, let's take a look at another one where we actually have to do step 1 now. So step 1 is solve for a variable. So let's take a look at the two equations that I'm given. The first one is x plus 4y equals 6. And if I were to ask myself, which variable could I solve for here? I could solve for x. That would be quite easy because I could just move 4y to the other side of the equation. In the second equation, I have x plus y equals 3. And in this equation as well, I could solve for x or y. It wouldn't matter. I would just move my y or my x to the opposite side of the equation. So let's go ahead and do that. I might go ahead and solve the second equation. Like I said, it doesn't really matter which one you do that for. And I'm going to solve for x this time. So I have x plus y equals 3, and I'm going to solve for x. To solve for x, I'm going to subtract y from each side, and I get x equals 3 minus y. So now I'm going to take what x equals, 3 minus y, and I'm going to plug it into the opposite equation. So the opposite equation was x plus 4, y equals 6. And this is step 2. Step 2 says plug or substitute what you found your variable to be into the variable for the opposite equation. So now I'm going to put that 3 minus y right into this x. So now I have 3 minus y in for x. I'm going to add the 4y equals 6. And now I'm going to combine like terms and solve for y. And that's step 3. Step 3 asks us to solve now for the variable. I know that my substitution should have gone correctly because I now only have y's. There are no x's. So let's go ahead and solve for y. Here, if I combine like terms, I'm going to get 3 plus 3y equals 6. And then I'm going to go ahead and solve for y by subtracting 3 from each side. I get 3y equals 3. Divide by 3. And I should get y equals 1. Step 4 now says, okay, now that you know what your variable equals, go ahead and plug it into one of the two equations. I'll go ahead and plug it into the first one since that's not the one that I solved for. It's here, this is x plus 4y equals 6. If I plug in my y to be 1, this becomes x plus 4 equals 6. Subtract 4 from each side, and I get x equals 2. Step 5 finally says, write this as an ordered pair. That's your solution. So the ordered pair here would be 2, 1. If you need to, take a minute, pause, rewind, go back to any steps that you're not familiar with. Let's take a look now at another problem. Okay, so like the last example, now I have to solve again for a variable because neither equation has x or y solved for on one side of an equation. My first example, or my first equation, 4y minus 5x equals 9. I could solve for x or y in this equation, but I think the second equation is going to be easier. X minus 4y equals 11. If I take a look here, I can easily solve for x simply by adding 4y to both sides. So I'm going to start by doing that. Step 1 asks me to solve for a variable. So I'm going to take x minus 4y equals 11, and I'm going to solve by adding 4y to both sides. And here I get x equals 11 plus 4y. So I know that this is what x equals. X is equal to 11 plus 4y. And step 2 says, okay, great. Now plug that, what you know x to be, into the opposite equation. So I would take the opposite equation, 4y minus 5x equals 9. And I'm going to plug in what I know x to be, which is 11 plus 4y, and plug it into the x of the opposite equation. So now I'll have 4y minus 5, and because the 5 here was multiplying by the x, I need to make sure that I put this in parentheses. 11 plus 4y equals 9. Now I can solve. I have only y's in this equation, so let's go ahead and solve for y. The first thing I do is distribute. My 4y stays the same here. Negative 5 times 11 is negative 55. Negative 5 times 4 is negative 20y. And that's all equal to 9. Now I combine my like terms, 4y and negative 20y. That will leave me with negative 55 minus 16y equals 9. I'm going to add 55 to both sides to get y alone. And I get negative 16y equals 64. Finally, I'm going to go ahead and divide by negative 16. 64 divided by negative 16 is just negative 4. So now that I know what y is, that was my step 3 to solve for y, I can plug it back into either one of the first equations, y equaling negative 4. I think I might plug it into the second equation. It doesn't really matter here, but let's go ahead and do the second equation. Y minus 4y, or x minus 4y equals 11. And I'm going to plug in this negative 4. So I have x minus 4 times negative 4 equals 11. Well, negative 4 times negative 4 is a positive 16. And I subtract 16 from both sides then. And I find that x is equal to negative 5. And then step 5 says simply write it as an ordered pair. X, which is negative 5, comma, y, which is negative 4. You can always check your answer by plugging these back in. They should work for both equations. 4 times negative 4 is negative 16, minus 5 times negative 5, which is negative 25. Negative 16 minus negative 25, which becomes plus 25, is equal to 9. So it should work for both equations. Go ahead, pause the video here, Try this one on your own, then press play to check your answer. If you need to pause the video or go back to check your answer, your final answer should be 3, -10. Okay, let's take a look at a couple of word problems. The first problem says, David earns $1.50 more per hour than Peter. Together, they earn $950 if they both work 40 hours in a week. How much money per hour do David and Peter earn? So the first thing that I do whenever I do a word problem is I try to define my variables. In this case, we're going to have two variables. We're writing a system of linear equations. We definitely need to have two variables. And I always try to look at my last sentence to help me out with that. How much money per hour do David and Peter earn? So we're going to have two things. How much money does David earn and how much money does Peter earn? And it's important to be specific about that because let's say I use the variables D and P. D does not stand for David. D stands for David's wage, how much money he earns per hour. And P doesn't just stand for Peter, it stands for specifically Peter's wage. And these are all dollar amounts or quantities. We need them to be numerical. Okay, so now that we know what our variables are going to be, let's go and try to write some equations. Going back to the problem, David earns $1.50 more per hour than Peter. So David's wage should equal Peter's wage plus $1.50. So in the end, David is equal to Peter plus $1.50, Peter's wage. Then we need another equation because this is a system. It says together they earn $940 if they both work 40 hours in a week. So we want them to equal a total of $940. So they both have to work 40 hours a week, and we need to use our two variables, David's wage and Peter's wage. Well, if I multiply 40 hours times David's wage, that's 40 hours times his wage. So let's say he makes $8 an hour. Then you can figure out how much money he made that week. I need to add that too because together means add if Peter works 40 hours. So 40 times Peter's wage. And together we want that to equal 940. I'm just going to make that 40 a little nicer. Okay. So now I have my two equations and I can choose to solve. I'm going to solve using substitution like we've been doing. Nicely, D is already solved for in my first equation, so I don't have to solve for a variable. And I can just plug in what D equals into the D of the opposite equation. So let's do that. So I'm going to have 40 times what D is, P plus 150. and then finish out the rest of the equation. Plus 40p equals 940. I should only have one variable in my equation now, that's p, so I'm going to go ahead and solve for p. First, I have to distribute the 40. So I'm going to get 40p plus 1 times 40 is 40. A half of 40 is 20, so 1.5 times 40 is 60. And then I have plus 40p equals 940. Add my like terms, 40p and 40p is 80p. Plus 60 equals 940. And now I'm going to subtract 60 from each side. So I get 80p. And 940 minus 60 is going to give me 880p, or 880. Final step, divide by 80. So 80, we can think about this as being 88 divided by 8 because our zeros are the same. And so 88 divided by 8 is 11. So I know that Peter earns now $11 per hour. So I can say P is equal to $11 per hour. Okay, and I need to go back then and figure out what David's wage is. So we know that David is Peter's wage plus $1.50. And since I now know what Peter earns, $11, I can add that $1.50 on. And I find that David equals $12.50. Okay, so now you've seen one word problem be done. Go ahead and try to do this one on your own. Try to see if you can set up what the variables are and what the equations are. Pause the video here and then press play to check your answer. Okay, the variables that we have here should be length and width. Length and width are both numbers, and they should be easy to write down. So I have my length and my width. My equations, the length is twice the width, L equals 2W. And the perimeter of the angle is 30. I need to know the perimeter formula. It's 2L plus 2W equals 30. So what is the length and width? Go ahead and solve. So I found by solving the system that my length is equal to 10 and my width is equal to 5. If you have any questions, please see Mr. Daniels or myself, and go ahead and have a great time doing your homework.